refocus here. A is the distance from the center to the vertices. B is the distance from the center to the co-vertices. We covered all this yesterday. Just reminding ourselves because this is the specific information that we're going to need to use here. So to find the foci, we use the formula c squared is equal to a squared minus b squared. All right, so let's start. First one that we're going to look at is if we are given a graph. If we're given a graph, let's look at number one. We need to write the equation, then we need to identify the center, the vertices, the co-vertices, and the foci. So with the way that this one is oriented, it's horizontally oriented. It's wider than it is tall, so we know that x is going to be over the bigger number. This one has a center at the origin, so we're not going to add or subtract anything from our x or our y because it's a center at 0, 0. If it was somewhere else, just remember you change that sign. When you put it in there, you change the sign. Let's go ahead and identify these other characteristics before we build the equation. Since we're given the picture, it's pretty easy to identify your vertices and your co-vertices. Remember, the vertices are on the major axis, the bigger axis. So let's see here, what is that? 2, 4, 6 in both directions. So we've got -6, 0, and +6, 0 for the vertices. Our co-vertices are the points on the minor axis, so that's 4 and -4, so 0, 4, and 0, -4 are the points or coordinates of our co-vertices. Our foci, we're going to have to do a little calculating before we get to the foci. So let's remind ourselves, where did these numbers come from? A is the distance from the center to the vertices. So that distance is 6. We square it when we put it into the equation. So it's x squared over 36. B is the distance from the center to the co-vertices. That distance is 4. We square it when we put it into the equation, so it's over 16. To find the foci, we use the formula c squared is equal to a squared minus b squared. So c squared is equal to a squared was 36, b squared was 16. So c squared is equal to 20. Let's practice simplifying that. That's 2 square roots of 5. When we take the square root of 20, it simplifies to 2 square roots of 5. Our foci are on the same axis as our vertices. It's that many units from the center. Okay, so our center was 0, 0. So our foci will be at positive 2 square roots of 5, 0, and negative 2 square roots of 5, 0, because they're on the x-axis there. And that number is about 4.5. So you could plot that if you wanted to, put them on there so you can see where they're at. Okay? So it all comes down to what's in that box as far as figuring out the information that you need to put in your equation. So pretty easy when you're given the graph. Let's look at, flip the paper over. Let's look if they give us more information. They don't graph it for us, but they give us some information. So if we're given the vertices, the co-vertices, and or the foci, what do we need to do? Well, step one, we need to identify the center from the vertices and or co-vertices. It says on here, use your midpoint formula. The center is right in the middle of both your vertices and your co-vertices. So we use the midpoint formula. Use the vertices to find A, because remember the distance between the vertices is 2 times A. So we can divide that by 2. Use the co-vertices to find B. If you're given the foci, use that other formula, and then determine the direction of the ellipse. So let's look at one of these and break all this down. Let's look at number 6. We'll do a vertices and co-vertices one, and then we'll do a vertices and a foci one. Let's look at number 6. I think it's helpful to sketch a little graph. Okay, sketch yourself a little graph so you can get a visual of what's going on here. We have vertices at -5, +1, and at +1, +1. We have co-vertices at -2, 3, -2, 3, and -2, -1. So all we're doing here is we're giving ourselves a little bit of a visual of our ellipse so we know what to expect out of our formula. So this one is horizontal. It is wider than it is tall. The distance between the vertices are on a horizontal axis, and the co-vertices are on a vertical axis. So this is going to be, X is going to be over A. I'm just making a little note of that to the side. All right, so use our midpoint formula to find the center. So midpoint, you add the x's, divide by 2. You add the y's and divide by 2. So -5 + 1 is -4. -4 divided by 2 is -2. 1 + 1 is 2. 2 divided by 2 is 1. So -2, 1 is our center. So let's go ahead and put that into our formula. Change the sign, x minus the x coordinate squared. We don't know what it's over. Y minus the y coordinate squared. We do know that it's always equal to 1, because our ellipse is always equal to 1. All right, so we've got our center. We need to find our A, and we need to find our B. Okay, we need to find our A, we need to find our B. So from -5 to +1, that's a distance of 6. The whole thing is 6. So the A is from the center to the vertices, so that would be 3. So 3 squared is 9. For our minor axis here, from top to bottom, we're going from a y value of 3 to a y value of -1. That's a distance of 4, but we only need half of that, so that's 2. 2 is our B, so we square it and we get 4. So that's our equation. That's our equation. We don't need to, we won't find the foci because we just needed the equation. Okay, let's look at number 8. Well, no, let's not do number 8. Let's do a different one. Let's do number 11. Do number 11. Actually, I changed my mind. I want to do number 10 because I want to do a vertical one. We haven't done a vertical one yet. All of the ones that we've done have been horizontal. Number 10, co-vertices are at -5, 0 and +5, 0. So again, draw yourself a little picture. +5, 0, -5, 0 are co-vertices. Our foci are at 0, 12. Let me do this in a different color so I don't think that they're the vertices. 0, 12, and 0, -12. So my ellipse is going to look something sort of like this. Okay, the purple points are the foci. The foci are not on the ellipse. The foci are inside the ellipse. All right, so we need to find our center. Okay, to find the center, we do the midpoint of the co-vertices. So 5 plus -5 divided by 2, 0 plus 0 divided by 2. I think it's kind of obvious that the center is the origin, 0, 0. So that makes our equation pretty simple. X squared plus y squared. We gotta find A and B. We're going to find A and B. So this one's vertical. So y squared is going to be over A. X squared is going to be over B. So our distance here for our minor axis is 5. X squared is going to be over 25. Now our foci are C units from the center. So if they're at 0, 12, and 0, negative 12, that means they're 12 units from the center. So C is 12. Our formula says C squared is equal to A squared minus B squared, right? Yeah. I don't know why all of a sudden I thought that it should be B squared minus A squared. A squared minus B squared. We don't know A squared because we don't know what our vertices are. We know what our foci are. We don't know A squared. We do know B squared, though. B squared is the distance to our co-vertices. So we have 144 is equal to A squared minus 25. 144 plus 25 is 169. So that makes our A 13. Well, might as well leave it A squared, right? Because that's what goes in our formula. A squared is 169. Let me do one more like that because I feel like my explanation was a little scattered. Okay, let's do number 11 as well. Co-vertices at 2, 7, and 2, negative 9. 2, 7, and 2, negative 9. 2, 7, 2, negative 9. Those are our co-vertices. Our foci are negative 4, negative 1, and positive 8, negative 1. Not very centered here on my picture, but our ellipse looks something sort of like that. I'm not very good at drawing that one. All right, center, midpoint of the co-vertices. So 2 plus 2 over 2, 7 plus negative 9 over 2. So that's 2, negative 1. So let's plug that into our formula. We've got x minus the x coordinate squared plus y minus the y coordinate squared, so y plus 1. This one's horizontal, so x squared is over the bigger number. But this time we can find the number that goes over y a lot easier, because if we calculate the distance from our center at 2, negative 1 to either co-vertice, right? To get from negative 1 to 7, it's 8. To get from negative 1 to negative 9, it's 8. So that's over 8 squared, 64. Y terms over 64. We need to find a squared using c squared equals a squared minus b squared. So we know b squared. We don't know a squared. We can find c squared. C is the distance from the center to the foci. So from positive 2 to 8 is 6 units, or from positive 2 to negative 4, that is 6 units, so c is 6. So c squared is 36. 36 plus 64 is 100. So 100 is our a squared.